Greetings everyone, I am Dr. Yubaraj Sharma, Assistant Professor, Department of Physics, Don Bosco College, Tura, Meghalaya, a state lying in the northeastern part of India. My presentation is on calibration of microscope-camera assembly using stage micrometer images. An important but overlooked aspect in measurements using images from a microscope is the calibration of the image. Usually, the average of a few manual measurements are taken with the help of a stage micrometer to establish the relationship between the image scale and the real-world scale. That is to find a connection between number of pixels in images and their value in meters, centimeter, etc. That is the real-world length units. Our main area of research is in the field of solid-state nuclear track detectors, abbreviated as SSNTDs, which are basically detectors of nuclear radiation. The nuclear track is nothing but an enlargement of the path that an energetic heavy ion takes inside the detector material. The images of the tracks are captured under a transmission microscope, which are then used in measurement of nuclear track parameters like the length, diameter, density, etc. This is an image of nuclear tracks of about 13 MeV per nucleon xenon ions in macropholy detector, whose length and diameter is usually our area of interest. And these are the nuclear tracks of alpha particles in LR115 detector. In this presentation, we discuss a simple image analysis routine or algorithm to compute the calibration of images taken under a microscope using standard computer vision tools. We have divided it into three sections: the segmentation, post-processing, measurement, and statistical analysis. In the segmentation part, the first thing we do is to convert the image from a color image to a grayscale image. This is done because in our case the colors do not convey any useful information and can be safely discarded, and also to reduce computation costs. In our conversion process, we have given equal weightage to the red, blue, and green channels of the RGB image. You can see here that there is not much of a difference between the original color image and the grayscale image. The grayscale image contains noise, that is unwanted parts and non-uniform illumination, which makes simple segmentation methods like global thresholding to be inaccurate. We use the classic unsharp filter to sharpen the image so that the edges in the object of interest become clearly defined. We can clearly see the improvement in the outline of the objects of interest due to the unsharp filter. The enhanced image is now suitable for global thresholding, and we use the Otsu method to find the threshold. Here we see the change brought about by thresholding. The image has been inverted so that the object of interest is marked by white pixels with black representing the background. Thus we achieve segmentation. In the post-processing stage, we remove unwanted parts from the segmented image. To remove small objects, we proceed as follows. Any object in the image whose dimensions are smaller than 1/3 of the largest object is removed. As you can see, the previously described method removes artifacts. The image is then cropped to remove the blank region around the object of interest. The cropping is done by looking at the starting and ending rows and columns that have zero sum. To reduce the size of the markings of the stage micrometer to a single pixel line, we use morphological thinning algorithm. As you can clearly see, thinning has produced extra unwanted artifacts, which are removed by a series of procedures outlined in the next few slides, which due to lack of time I will not pursue further, but feel free to pause the video to look at the. The code shown is written in MATLAB programming language. In the measurement and statistical analysis section of the algorithm, we measure the distance between two consecutive lines of the slide micrometer from the straightened and cropped image and perform statistical analysis on the obtained values. Most importantly, we get the standard deviation, which is useful in understanding the accuracy of the calibration factor being used and not usually available with the more traditional approach. In this slide, we show the results on a test case. Thank you all for hearing me out.